This video will focus on planning the turnaround, exploring the engineering architecture of bottom-up plant maintenance. A turnaround is a radical engineering intervention that requires shifting from a single company routine to a systems perspective to understand hidden interconnectivity. Turnaround planning differs significantly from top-down project planning. Standard projects build down from a known definition. Turnarounds, however, build up from an undifferentiated work list and an unknown reality until equipment is opened. Creating a master plan involves specifying the right job, scheduling the right time, and resourcing the right people. This requires integrating knowledge from multiple sources, including plant personnel, suppliers, contractors, and inspectors, and resolving the proposal, discussion, decision, action cycle. The task planning categorization matrix ensures that planning rigor matches risk. Tasks are categorized as major, small, or bulk work. The golden rule is that any borderline task must default to the higher category to ensure safety and depth. The task planning documentation checklist creates a quality trail and ensures single-point responsibility. Key documents include task method statements, task networks, isolation registers, and a detailed task safety plan. The typical job sequence involves running down the product, isolating the plant, installing preparations, performing tasks, and finally boxing up and testing. Visualizing these natural job steps helps expose obstacles and avoid time lost in the white space between handovers. Choosing a management quadrant is critical. Options range from Quadrant 1, which offers low execution risk but high production loss duration, to Quadrant 4, which offers zero interface problems but is highly vulnerable to local plant knowledge gaps. The scheduling engine balances conflicting objectives by processing inputs like work lists and constraints. It refines and smooths resource profiles to ensure that the plant does not hit its saturation point. Regardless of the tool, human engineering judgment, not the computer, plans the turnaround. Both the algorithm and the shuffleboard help visualize the critical path tasks where lost time cannot be recovered. Optimization involves the continuous cycle of manipulating shift patterns, smoothing resource profiles, and re-estimating costs within the constraints of duration, resources, and budget. Contingency planning requires engineering judgment to guess the unknown condition of equipment. We must plan for the unknown, or emergent work, such as hidden faults or internal corrosion. Planners must rely on engineering judgment and historical data to inject specific time and cost contingencies into the critical path. A perfect plan must be monitored. Control documents, such as resource profiles, daily task sheets, and performance trackers, bridge the gap between theoretical planning and physical execution. These documents help trigger immediate corrective management action.